Hello students, welcome to Well Explained Pedia. Today I am here with part 3 of class 9 chemistry. Is matter around us pure? And in this part we are going to learn about solutions, suspensions and colloids. Students, coming to solution. A solution is a homogeneous mixture of two or more substances. Okay? If two or more substances are mixed and they are mixed homogeneously, as we have studied in our part 2 about homogeneous and heterogeneous mixtures. Homogeneous mixture means the solute and the solvent both are uniformly mixed with each other. Now what is a solute and what is solvent? Solute is the component of a mixture which is in lesser amount, okay, and whereas solvent is the component of the mixture which is in larger amount. Suppose if we talk about sugar solution, okay, in this sugar is the solute and water is the solvent because sugar is dissolved in water. The sugar is the solute and water is the solvent because sugar is in lesser amount whereas water is in more amount. The solution has a solvent and solute as its components. The component in the larger amount is the solvent and the component in the lesser amount is the solute. Means you have to remember these two things. What is a solvent and what is a solute. Example of solutions are solution of salt in water. Here salt is the solute, water is the solvent. Solution of sugar in water. Here sugar is the solute, water is the solvent. Iodine in water, which is known as tincture iodine. Iodine is the solute, water is the solvent. And soda water, that is in soda water, carbon dioxide is the solute which is dissolved in water. Now, what are the properties of true solutions? True solutions are simply called as solutions also. True solution is a homogeneous mixture. The particles cannot be seen by the naked eye, means the particles are very small. They are extremely small and the size of the particle is less than 1 nanometer in diameter. 1 nanometer is equal to 10 to the power of minus 9 meters. The particles of the solution, they are so small that they cannot be even seen with the help of a microscope. The solute particles cannot be separated by filtration. As we know, the particles are very small, so they pass through the filter paper. The solute particles, they do not settle down and the solution is stable. Means we cannot find out the solute and solvent as different components as the solute particles do not settle down. The particles do not scatter a beam of light passing through it and the path of light is not visible in the solution. So if you throw light from a torch through the true solutions, the light will pass like that only, means no path of light is visible in the solution. In this you can see this is a solution of copper sulfate crystals. They are the solute because copper sulfate is in small amount and water is solvent. When copper sulfate is dissolved in water, we get a true solution of blue color because copper sulfate crystals are blue in color and this solution is also of blue color. Now, examples of true solutions are solution of solid in a solid, that is metal alloys. Brass is a mixture of zinc and copper. Solution of a solid in a liquid. We can give example of sugar solution. This is the most common type of solution. Then solution of liquid in a liquid. Example is vinegar, as vinegar is a solution of acetic acid in water. Okay, acetic acid in water. Then solution of a gas in a liquid. Example is soda water. In this carbon dioxide is mixed in water. And solution of gas in a gas is air, as air is a mixture of gases. These all are different types of solutions. Now come the second category, that is the suspensions. Now a suspension is a heterogeneous mixture of two or more substances. Solution was a homogeneous mixture of two or more substances, whereas suspension is a heterogeneous mixture of two or more substances. Example: solution of sand in water, solution of chalk powder in water, solution of flour in water, and muddy water. They all are example of suspensions. Why? Because suspensions, before using, we have to be shake them well. Otherwise, the solute and solvent, they are not mixed properly with each other. Now, what are the properties of suspension? Suspension is a heterogeneous mixture. Heterogeneous mixture means the components or the constituent of mixtures, they are not uniformly present. The particles can be seen by the naked eye. This means that the particles, the size of the solute particles in a suspension is quite large. It is larger than 100 nanometer in diameter. In solution, it was less than 1 nanometer, but whereas in suspension, it is more than 100 nanometer in diameter. As the solute particles are large enough, they can be separated by filtration. We can separate the solute from the solvent in suspension with the help of the process of filtration. The solute particles settle down and the solution is unstable. Why they settle down? Because the particles are very big. Okay. Then particles scatter a beam of light passing through it, and the path of light is visible in the solution. That is, as the particles are quite large, so they can make the path of light visible. Okay. Now next category is the colloidal solutions. A colloidal solution is a heterogeneous mixture of two or more substances. This is also, we can say, the colloids are in between the true solutions and suspensions. They have some properties of solutions and some properties of suspensions. So it is a heterogeneous mixture of two or more substances. The particles cannot be seen by the naked eye, means the particles are in the range of 1 nanometer to 100 nanometer. The particles of the solutions were smaller than 1 nanometer. The particles of suspensions were greater or larger than 100 nanometer in diameter, whereas the particles of colloidal solutions are between 1 nanometer and 100 nanometer in diameter. Therefore, they cannot be seen by the naked eye. The solute particles cannot be separated by filtration. So, as the particles are intermediate between a solution and a suspension, they cannot be separated by filtration. They are small, they will pass through the filter paper. The solute particles, they do not settle down and the solution is stable. Means the colloidal solution is stable as the solute particles are not large enough to be settled down. The particles scatter a beam of light passing through it and the path of light is visible in the solution. The particles are not as big that they can be settled down. वो settle down तो नहीं हो सकते हैं, but they are big enough to scatter the beam of light passing through it. You can see this is a colloidal solution. Now what is Tyndall effect? Okay. When a beam of light is passed through a colloidal solution, this Tyndall effect is shown by the colloidal solution. The colloid particles, they scatter the beam of light and the path of light becomes visible in the solution. And this effect is called as Tyndall effect. This Tyndall effect can be seen in our daily observation also. When light enters a room through a small hole due to the scattering of light by the dust and smoke particles. Okay, when you broom the house, झाड़ू लगाते हैं, उसके अगर आप तुरंत बाद देखिए अगर वेंटिलेटर से लाइट आ रही है, beam of light is entering through the ventilator, you can see that the particles, they are moving very fast in that beam of light, means that beam of light is visible to us because of the colloidal solution. This Tyndall effect can be seen in a dense forest due to the scattering of light by water droplets in the mist. Okay, you can see this path of light is visible in this, the path of light is visible in this, and the path of light is also visible in this, in the forest, dense forest, because of the mist. Now the classification of the colloids, means types of colloids. Number one is Sol. Sol is a colloid in which tiny solid particles are dispersed in liquid medium. Sol means solid in, you can say SO, solid, L for liquid, solid in liquid. Example, ink, soap solution, starch solution, and most of the paints, they are sol. Second is solid sol. As the name is suggesting, solid in solid. In this, solid particles are dispersed in a solid medium. Example, colored gem like ruby, emerald, etc. Number three is aerosol. Aerosol means in which a solid or a liquid is dispersed in a gas. Example are smoke and automobile exhaust for solid in gas. Okay, and hairspray, fog, mist, and clouds for liquids in a gas. So you can give examples from this. Number fourth is emulsion. Emulsion is a colloid in which minute droplets of one liquid is dispersed in another liquid, means liquid in liquid. Example are milk, butter, and face cream. Number fifth is foam. It is a colloid in which gas is dispersed in a liquid medium. Okay. Example, soap bubbles, fire extinguishers, and shaving cream. Okay. This I is not there. Soap bubbles, fire extinguishers, and shaving cream, they are example of foam. Next variety of colloid is solid foam. In this, a gas is dispersed in a solid medium. Example, insulating foam, sponge, foam rubber, and bread. Bread is also a gas which is dispersed in a solid medium. Number seventh, gel. Gel is a semi-solid in which there is a continuous network of solid particles dispersed in a liquid. For example, jellies, hair gel, and gelatin. Now coming to the concentration of a solution. Now what do we mean by concentration of a solution? Concentration of a solution, we know that a solution is formed when a solute is mixed in a solvent. Solute is mixed in a solvent. What is formed? A solution is formed. Okay. Now, concentration of a solution means that the amount of solute present in a given amount of solvent or in a given amount of a solution. Now, this concentration of a solution is expressed in two ways. Okay. Mass by mass percentage or mass by volume percentage. Okay. Now, mass by mass percentage of a solution is calculated by mass of solute upon mass of solution into 100, because for converting or calculating percentage, we multiply the amount by 100. And mass by volume percentage of a solution means mass of solute into volume of solution into 100. Mass of solute upon volume of solution into 100 is the mass by volume percentage of a solution. You have to learn these two formulas. They will be used for solving the numericals. Now coming to saturated and unsaturated solution. A saturated solution is a solution which cannot dissolve any more of a solute at a given temperature. Means जो saturated solution है, we know solution means solute in solvent. Okay, so if it cannot dissolve, if a solution cannot dissolve any more of a solute at a particular temperature, then it is said to be saturated solution. Now, solubility of a substance is the amount of solute present in a saturated solution of the substance. Now, coming to unsaturated solution, it is the opposite of saturated solution. Unsaturated solution is a solution which can dissolve some more of the solute at a given temperature. Okay. अगर हम और सोल्यूट नहीं डिसॉल्व कर सकते हैं किसी सोल्यूशन में एट अ पर्टिकुलर टेम्परेचर देन इट इज अ सैचुरेटेड सोल्यूशन. और अगर हम और सोल्यूट डिसॉल्व कर सकते हैं एट अ पर्टिकुलर टेम्परेचर इन अ सॉल्वेंट देन इट इज नोन as an unsaturated solution. Now, how can we prepare a saturated solution? We'll take 50 ml of water in 2 beakers. Okay. Add salt in 1 beaker with continuous stirring. पहले हमने एक बीकर लिया और उसमें 50 ml 2 बीकर लिए. We took 2 beakers. एक में हमने 50 ml of water लिया और उसमें हमने क्या डिसॉल्व किया? Salt with continuous stirring. और तब तक डिसॉल्व किया till no more salt dissolves in it. Okay. Similarly हमने क्या लिया? दूसरे बीकर में भी पानी लिया. We added sugar in the other beaker with continuous stirring till no more sugar dissolves in it. Okay. 2 बीकर में पानी लिया 50-50 ml. एक में हमने सॉल्ट ऐड करना शुरू किया करते गए विद कंटिन्यूस स्टरिंग मींस चम्मच से चलाते रहे उसे. कब तक? जब तक कि और सॉल्ट उसमें डिसॉल्व नहीं हुआ. दैट मींस इट बिकेम अ सैचुरेटेड सॉल्यूशन. सिमिलरली दूसरे बीकर में भी 50 ml ऑफ वाटर लिया और उसमें हमने क्या ऐड करना शुरू किया? शुगर. और ऐड करते गए विद कंटिन्यूस स्टरिंग टिल नो मोर शुगर डिसॉल्व्स इन इट. नाउ we get saturated solutions of salt and sugar. If the mixtures are heated, it dissolves some more of the solute. अगर हम इसी mixture को heat करेंगे, तो we will be able to dissolve some more of solute. And the solubility of different substances are different. It varies with temperature. Okay. Now, what is solubility? Solubility refers to the maximum amount of solute expressed in grams that can be dissolved in 100 gram of water. Water, or we can say water is a universal solvent. So for most of the cases we use water as a solvent. So here it is water, but we can use solvent word also here. And at a specific temperature and pressure. तो जो मैक्सिमम अमाउंट ऑफ सोल्यूट हम किसी भी सॉल्वेंट में डिसॉल्व कर सकते हैं. ठीक है. दैट amount of solute should be expressed in grams and water or solvent should be in taken as 100 gram. So that is known as the solubility of a substance at particular or specific temperature and pressure. Now, substances may be soluble or may be insoluble. If a substance dissolves in a solvent, it is known as soluble. And if a substance that does not dissolve in a solvent, it is known as insoluble. Okay. Here we can give example of sugar, salt, because sugar and salt both are soluble in water. Okay. Here the example is sand, because sand is insoluble in water. You can see here sugar, salt, sand, they all are solids. तो अगर हम solid और liquid की बात करेंगे तो we use the term soluble and insoluble. If you see this test tube, at the top it is soluble, then slightly soluble, and at the bottom it is insoluble. Now, if our solute is liquid, if the solution is liquid in liquid, so we use the term immiscible and miscible. Okay, immiscible and miscible. If two liquids that are insoluble, then it is known as immiscible. Oil and water, petrol and water, oil and vinegar. So these are immiscible liquids because they do not get mixed. Whereas two liquids that are soluble in each other, that can be mixed, they are known as miscible liquids. Say alcohol and water, we can give example of vinegar and water also. Suppose our solvent is oil. Water is immiscible in oil, kerosene is miscible in oil, acetone is miscible, and alcohol is semi-miscible, means some amount of it can be soluble in oil. Now, degree of saturation. We have learned about saturated solution. Solvent holds as much solute as is possible at that particular temperature. Undissolved solid remains in the flask. Undissolved solute जो है, it is in dynamic equilibrium with solid solute particles. So these are the properties of a saturated solution. Solvent में maximum amount of solute आ जाएगा, ठीक है, at particular temperature जो भी वो hold कर सकता है. जो अनडिजॉल्व सॉलिड होता है वो फ्लास्क में रह जाता है, और जो डिजॉल्व सोल्यूट होता है, डिजॉल्व सॉलिड इन दैट सॉल्वेंट, that is in dynamic equilibrium, means equilibrium रहता है with solid solute particles. Now, degree of saturation. On the basis of the degree of saturation, solutions are unsaturated and saturated solutions, as we have learned earlier. In unsaturated solution, the solute is less than the maximum amount of solute for that temperature is dissolved in the solvent. Means we can dissolve more and more solute in that solvent. There is chances of dissolving more, and no solid remains in flask. So this is unsaturated solution. Now, factors affecting the solubility. This solubility is affected by few factors such as temperature, pressure. So we are going to learn those. The first factor which affects the solubility is the temperature. Generally, the solubility of solid solutes in liquid solvents increases with increasing temperature. This point is to be noted. Okay, the solubility of solid solutes in liquids, it increases with the increasing temperature. The opposite is true for gases. Higher the temperature drives gases out of the solution. Means in case of gases, the solubility decreases with the increase in temperature. Carbonated soft drinks are more bubbly if stored in the refrigerator. आपने तभी देखा होगा, अगर chilled आपको cold drink है तो वो ज्यादा tangy sensation देती है, bubbly होती है, जबकि अगर बाहर रखी हुई है तो उससे आपको उतना मजा नहीं आता. Why? Because बाहर जो रूम टेम्परेचर पे जो कोल्ड ड्रिंक है, कार्बोनेटेड सॉफ्ट ड्रिंक है, that in that gases is expelled out. This bubbly sensation is given by the gas which is mixed in the solvent. Warm lakes have less oxygen dissolved in them than cool lakes. Now, effect of stirring. When we are preparing a solution and while dissolving a solute in the solvent, if we stir, means अगर हम उसको चलाते हैं, तो it increases the speed of the process. It increases the movement of the solvent that exposes solute, thus enabling solubility. Means solubility increases. As molecules in liquid substances are in constant move, the process would take place anyway, but it would take more time. मीन्स अगर हम 2 ग्लास लें, पानी लिया हमने, एक में 1 स्पून शुगर डाला, दूसरे में 1 स्पून शुगर डाला. ओके, एक को ऐसे ही छोड़ दिया, एक में स्टरिंग किया. तो जिसमें हम स्टरिंग करेंगे दैट विल डिसॉल्व मोर फास्टली. डिसॉल्व वो वाला भी होगा जिसमें हम स्टरिंग नहीं कर रहे, बट इट विल टेक मोर टाइम. Now, in cases in solution, increasing pressure above solution forces more gas to dissolve. That means the solubility of liquids and solids does not change appreciably with pressure, but in gases it is directly proportional to its pressure. Means when the pressure increases, solubility increases, but in solids and liquids there is no effect of the change in pressure. Now, coming to types of changes, this you must have studied in your previous classes. Physical change and chemical changes. A physical change alters the form of a substance, but it does not change it to another substance. So a change in which no new substance is formed, okay, no properties of a substances are changed, that is known as a physical change. मीन्स फॉर्म तो चेंज कर सकता है, जैसे एक पेपर है, आप उसको टेयर कर दोगे, ठीक है, उसकी शेप साइज बिगड़ गए, बट इट विल रिमेन एज पेपर. तो इट इंक्लूड्स चेंज इन शेप और साइज, it dissolves, it changes phases, that is freezes, boils, evaporates and condenses. Means melting of ice, freezing of ice, boiling of water, condensation of steam, they all are physical changes. They only change the state of matter. Example, making orange juice. Now, physical change occur when matter changes its property but not its chemical nature. उसका chemical nature बिल्कुल नहीं change होता है, सिर्फ property change होते हैं. Physical property changes could include change in texture, shape, size, color, odor, volume, mass, weight and density. So these all are the physical properties which can be changed during a physical change. But no chemical properties are changed. As you can see that this freezing makes ice and melting makes water. This is a physical change. You must have observed disappearing of puddles. Means after rain, बारिश होती है उसके बाद जहाँ थोड़ा बहुत पानी इकट्ठा हो जाता है, थोड़ी देर बाद when the sun shines it disappears. So it is a physical change. Why? Because this water gets evaporated and changed into water vapor. Now coming to chemical change. Chemical changes are changes in which matter undergoes when it becomes new or different matter. जैसे in physical change we took example of tearing of paper. Paper फाड़ा हमने, paper ही रहा after tearing also. But if we burn this paper, then it will be a chemical change because it totally becomes a new or different matter. Means when we burn paper, it turns into ash and water vapor is produced and carbon dioxide is produced. Okay? When chemical changes can take place when it burns, when temperature changes without heating or cooling, when it bubbles, that means production of gas, when the change in color is there, or there is a formation of a precipitate. These all are chemical changes. When a substance undergoes a chemical change, it is changed into a different substance with different properties. Now, if we want to identify whether a change is a physical or a chemical, especially a chemical change, we will look for some certain signs. These are color change, bubbling, fizzing, light production, smoke and presence of heat. और इनमें से अगर कोई भी signs present है, that means it is a chemical change. For example, baking a cake is a chemical change. Now, signs of a chemical change is formation of precipitation. You can see this yellow precipitate here. The color change is there. You can see the leaves has changed their color. So these all are chemical changes. Production of gas is also a sign of chemical change. If the temperature changes, then it is also a chemical change. Now, a chemical change occurs when fireworks are used. Fireworks means जब हम पटाखे छोड़ते हैं तो क्या होता है, chemical change होता है. Fireworks are made up of metals such as magnesium and copper, and these change chemically as they light up in the sky. You can see the changes. The fireworks, they undergo a chemical change. Now all these are examples of chemical change. Rusting of matter, you can see here. Burning of toast. Here in this rocket, fuel is burning. Lighter, the chemical reaction is taking place. All these are chemical changes. Now that's all for this part. Part number 3 is ended. Now I'll soon meet with a new part, part 4, in which we'll discuss about the separation of mixtures. Till then, keep watching, keep learning. God bless you all.